Hello students, today we are going to study matter in our surroundings, part 3. Let us look into the contents. Latent heat of fusion, latent heat of vaporization, effect of change of pressure, evaporation, factors affecting the rate of evaporation, evaporation causes cooling, plasma state and Bose-Einstein condensate. Students, let us recapitulate the term latent, which we have studied in the previous class. Latent means lying hidden. During melting and boiling, the temperature of any substance remains constant at its melting point and boiling point because the heat supplied to the substance is used up in overcoming the intermolecular forces, and therefore it does not show up as a rise in the temperature. Depending upon the nature of the process, the kinds of latent heat are latent heat of fusion, latent heat of vaporization. Now let us define latent heat of fusion. The heat energy required to convert 1 kilogram of a solid into liquid at atmospheric pressure at its melting point is known as latent heat of fusion. Latent heat of vaporization. The heat energy required to convert 1 kilogram of liquid into gas at atmospheric pressure at its boiling point is known as the latent heat of vaporization. Effect of change of pressure. Gas to liquid. Gases can be liquefied by applying pressure and reducing the temperature. When a high pressure is applied to a gas, it gets compressed, and if the temperature is lowered, the gas is liquefied. Solid carbon dioxide gets converted directly to gaseous state on decrease of pressure to 1 atmosphere without coming into liquid state. This is the reason that solid carbon dioxide is also known as dry ice. This is a diagram representing interconversion of states of matter, the concept of which we have learnt earlier. Define evaporation. The process of conversion of a substance from the liquid state to the gaseous state at any temperature below its boiling point is called evaporation or vaporization. Factors affecting the rate of evaporation. Surface area. The rate of evaporation increases on increasing the surface area of the liquid. For example, sometimes we are in a hurry and we often put hot milk or tea in a saucer before sipping it. Since the surface area has increased, the evaporation becomes fast. As a result, the temperature of the liquid in the saucer gets lowered and we can sip the same quite comfortably. Temperature. The rate of evaporation increases with an increase in temperature. Actually, the increase in temperature also increases the kinetic energy of the particles or molecules of the liquid. They acquire greater tendency to change to the vapor state. As a result, the evaporation becomes fast. Humidity. Decrease in humidity increases the rate of evaporation. Wind speed. An increase in the wind speed increases the rate of evaporation. We often notice that the wet clothes dry fast on a windy day. Actually, with the increase in wind speed, the particles of water vapors present in air also move away and the air which replaces it is comparatively dry. This will increase the rate of evaporation. Evaporation causes cooling. During the process of evaporation, the particles of liquid absorb energy or latent heat of vaporization from the surrounding to get converted to gaseous state. This absorption of energy from the surrounding makes the surroundings cold. For example, the perspiration or sweating in our body keep the body temperature constant by taking away the extra heat from the body as the latent heat of vaporization. This is the fourth state of matter, plasma. Plasma have an indefinite shape and an indefinite volume because the particles can move past one another. Plasmas are easily compressible because there is a great deal of free space between particles. Let us know about the fifth state of matter, Bose-Einstein Condensate. Bose-Einstein Condensate is a state of matter that can arise at very low temperatures. The scientists who worked with the Bose-Einstein Condensate received a Nobel Prize for their work in 1995. The Bose-Einstein condensate is all about molecules that are really close to each other. With that, we come to the end of this chapter, Matter in Our Surroundings. Thank you.